Okay, students, now comes question number 20, and it is about distance between a point and a plane. So let's see how we can find this solution. Okay, so you are given a point and a plane is going to be determined from these 3 points, and we knew that these 3 points were given for you before. So we directly take the equation of the plane obtained before and here you see, and then we try to find the distance between the given point and the plane. Okay, is how we are going to do. So the solution runs like this. The equation of the plane containing the point 1, 0, minus 1, 2, minus 1, 1, and minus 1, 1, minus 2 is determined already, students, because we have calculated this one in our previous video. Please try to refer that. And it is obtained as x plus 3y plus z is equal to 0. So what do you think is a normal vector here? The normal vector to this plane is a vector with components as a coefficients of x, y, z, and it's a vector with components 1, 3, and 1, right? Because as we take the components of x, the coefficients of x, it's 1, coefficient of y is 3, and coefficient of z is 1. So the normal vector to this plane is going to be a vector with components 1, 3, 1, right? So what is required here is to find the distance between this point 4, 3, minus 1 and this one, this plane. Okay, so what I need to do is first let's substitute 4 in place of x and 3 in place of y and minus 1 in place of z. Can you get 0? Students, you can obtain that because the sum of these the sum of this is going to be 4 plus 9, 13. 13 minus 1 is 12, so 12 is completely different from 0. This shows you that the point is not lying on the plane. If the point is lying on the plane, the distance is obviously 0. But now the point is obtained to be, you see, obtained to be or obtained as a point that never lies on the plane. So we can now calculate distance between the point and the plane. It is expected to be a non-zero value, right? So how is that obtained? This basically is obtained by using the obtained formula. Basically, we have derived this formula in our classroom, so I'm going to apply that one. So let me clarify the formula. D is standing for distance, so the distance between the points, you see, the point what? X, the point with coordinate x naught, y naught, z naught, and a plane with equation ax plus by plus cz plus d can be obtained by using this formula. It is the absolute value of ax naught plus by naught plus cz naught plus d divided by the square root of the sum of the square of what, students? The coefficients of x, y, and z. So students, here in our case, we can consider a to be 1, b to be 3, and z to be what? C to be 1. Just take the coefficients of x, y, and z. And d is 0 because after z we don't have any number. That's implied that d is 0. And here x naught, y naught, and z naught are also given. Actually, they are components of the given point, 4, 3, and minus 1. So what we need to do is we directly substitute the given data here in place of their corresponding expressions or variables. So here a times x naught is required, a times x naught is 1 times 4, it is actually 4, b times y naught, we need to multiply these two, 3 times 3 makes 9, and c times z naught, 1 times minus 1, which actually is minus 1, as it is written. Then d says, so d is 0 because we don't have any number. You see to the right of this z, we don't have any constant. You see, how do we have that? We could have written that here. So d is 0, so I have that here. So square root of a square plus b square plus c square. So take the sum of the square of this, 1 plus 9 plus 1. So you are left with what? 13 minus 1, 12, and this is going to be 1 plus 9, 10, and 1, 11. So 12 square root of radical, 12 divided by the square root of 11 can come. So the distance between the given point and the plane is going to be 12 divided by square root of what? 11. This is how you can find distance between a point and a plane. And coming to the next one, we have question number 21, and here you are given two lines, and you have been told that these two lines intersect each other. So you are asked now to determine the distance between the point of intersection of the first two lines and the other line, right? The other line. So the parametric equation, the vector equation of the two lines are given in terms of t and in terms of q. So we first need to find the the point of intersection between r of t and r of q lines. And once you obtain that point of intersection, you are asked to find the distance between that point of intersection and the line. So it's a matter of finding or understanding, or it's a matter of recalling how you can find distance between a point and a line. Okay, but here what makes it different is we have to determine the point of intersection between these two lines, r of t and r of q. Okay, so the process goes like this. So first let us determine the point of intersection of the lines r of t and r of q. So for that, we have to have, to obtain the point of intersection, we have to consider, or we have to equate these two as t plus 2 to be the same as t2q, minus of 2t minus 1, the j component to match with the j component of the second one. So minus of 2t minus 1 being the same as minus of students, minus of 2k plus 1j, and t plus 3 must match with q plus what, students? 4. Now, student, there is one thing that I would like to tell you as a correction. Please, students, take this correction here. Instead of taking the j component of rq as negative of 2k plus 1, please make it plus, okay? Positive of 2k plus 1, students. Make it positive of 2k plus 1. Because I have wrongly written here that the j component for rq is negative, so make it positive, please. So in that way, please correct it. Now we have to find values of t and q that can satisfy this, because this is the point of intersection of the two. Because this point of intersection must lie at these two lines. It is a common point, hence we need to look for, okay, the values of t and q that can satisfy this. So from the first one, t is 2q minus 2. Alright? And from the last equation, as you see, from the last one we have t plus 3 equals q plus 4. So from this one we can move 3 to the right, and t plus 3 equals q plus 4 can be t plus 3 equals q plus 4 can be what, students? 2q minus 2. So in place of t, I just have substituted 2q minus 2, because here in place of t, 2q minus 2 is used, plus 3 equals q plus 4. So from this q3 and t4 can be obtained, okay? q3 and t4 can be obtained. Once you obtain that, try to substitute there in their corresponding place. So when you substitute the obtained values there, you can have the following one, students. You can obtain the following one. So the point of intersection is going to be 2qi minus 2q plus 1j plus q plus 4, okay? So as you are substituting these values, you will obtain this to be 2 times q, which actually is 6, and here minus is taken. Actually it was plus, because this is directly obtained had it been plus, because this is directly obtained when it is plus. But now again it is reversed. Anyway, student, please try to understand, the procedure. Actually it was plus, but just understand that was plus, but consider it now as a minus 1 in order to keep every other step. So minus 7 and 7 can come, students. Right, yeah, proceed please. Now what comes next is, this is a point of intersection in order to determine that one. So the point of intersection, where is the point of intersection now? 6 minus 7, 7 is the point of intersection, students. So how are you going to obtain now this distance then? Once the point of intersection is determined, as we stated before, the distance between the point and the line can be obtained by using the formula d equals p naught p cross v norm divided by norm of v, where p naught is an arbitrary point on the line. So you are free to take arbitrary point on this line. So as we did before, try to think of the case where this all can be 0, And when x is 1, this comes 0, and when y is 0, it is 0. When z is 1, it is 0. So you are free to take 1, 0, and 1, students. 1 point lying on the line. And the corresponding directing vector v is going to be, you see, the one that is obtained as a denominator. So this is 2, directly taken. This basically is y minus 0 over 1, so you can take 1 here. But here you need to be careful. This is written as 1 minus z, so it's up to you to write z minus 1, right? So when you write this in terms of z minus 1, the negative comes down, and it will be negative 3, students. So you need to take negative 3 here. So the directing vector is given, v is known, and what else is known, students? This an arbitrary point p naught is known. So the corresponding intersection point you obtain here is considered to be p. So this p is 6 minus 7, 7. So we can determine now p naught p. So this p naught p is nothing, but it is deducting what, students? P naught from p. So what you need to do is like this: 6 minus 1, it will be 5. And again, minus 7 is deduct, minus 7 minus 0 is minus 7. And here 7 minus 1 is 6. So you are left with p naught p to be 5 minus 7, 6. So you need to carry out now cross product between these two, p naught p and v. So as you are doing that, your p naught p is this, and your v is 2, 1, minus 3. So as you are taking the cross product, you are going to have this vector, as you see, 15i plus 27j plus 19k. So we need to find the norm of this, because that one is required in the numerator there. So this is going to be 15 squared, 225, 27 squared, 729, and 19 squared, 361. So as you are taking the sum, you will obtain this to be 1315. So this is considered as your numerator value. Now you have to determine also the denominator one, that is the norm of v. And the norm of v is nothing, but it is a norm of what, students? It is a norm of this one, this vector. So 4 plus 1 plus 9 is going to be taken, and this makes radical 14. So the distance between the intersection of what? The distance between the point of intersection and the plane is going to be radical 1315 divided by 14, students. It is in this way that you can obtain.